Hello. Alright, so welcome back. As you can see, I'm currently using AI a little bit because, I honestly just want to ramp up the production speed a little bit, or productivity, I should say. Well, if we look at what has been done, so basically MVP, so the MVP file now actually runs. We've got, the multiple arrays in with ranges, and what else? Well, we got the closures and everything. Those bugs were fixed. I basically used AI now to do that, because I felt like it was actually, we have to be careful, especially I felt like with this project. It's like it's easy for AI to do things that wasn't really your intention, but it solves it in like a weird way that was not your intention, that does not fit with like future ideas, and so we have to still be like careful. But yeah, I did a bunch of AI tasks here, and now, yeah, we've actually gotten quite far. However, there are still some things that we need to work on. So right now, I'm working on this one, which is, it's not a huge deal, but it's just one of those things where I would like it to work how Bash works. And it's okay. So the idea, the issue here of this one is that, let's say you have a program that outputs both standard out and standard error. And so when Bash captures that output and you use it, for example, you bind it to an identifier. So you basically have a variable that's set to some kind of like a process execution that has like both standard out and standard error. What happens in Bash is that it merges the output so that the result that's stored in the variable is actually a string that is, a result of both standard out and standard error merged. And they are kind of merged in a certain way where it's like, I think it's I'm not sure if it's like exactly how it's merged, because there are, race conditions and everything weird stuff can happen when you merge two streams together like that. But now, so what AI first did was that it just like concatenated like standard out, standard error. But I wanted it to be more, interleaved between each other so that it matches, the Bash behavior. But that was like, yeah, and that's what we are working on right now, me and and the AI here. And it said that, hey, now I've solved the problem, and then another problem came up. I tried to run mvp.rm and nothing came out. So now we've got a bug and it's trying to do something, and this is where I get a little bit suspicious of what AI is actually doing. Also, another issue is that AI right now works on like an older Zig version. So, but it is using like the output from Zig, build errors and stuff to fix things. But so, it can kind of work around that, but it's just that initial. Yeah, and here you can see it's trying an example here where you should see ABCD, I think, or ACBD, I guess. I'm not sure, but we're seeing like BD first, so we're seeing like the error first. Oh, I see. So first it should be A, B, C, D, I guess. But we're seeing like, yeah. So it's like, it's working on that. And so let's see what we can work on maybe in the meantime. So like the type checker in LSP is not super important. It was just fun to actually just make those things. Yo, Paul, what's up? Welcome back. How's it going? This one is also like, it's not really, I didn't even know about this since recently, like in Bash that you could push Control D to close standard in. I was just seeing that, okay, well, it doesn't actually work in Runic, so maybe we should just add support for it. But it's not really, I'm not gonna say this is MVP or anything. These things are probably not gonna be MVP, since the main purpose is to be able to write the scripts, not have these kind of support. But it would be nice to have them working, but yeah, it could be a potential future endeavor there. I just want to get a functioning version up. Oh, you're good, nice. And that's gonna be like the first version, and then I can go on to other projects. But I will probably keep working on this, like in the meantime, a little bit. We'll see what happens, but probably maybe not on stream. I'm not sure what's gonna happen, but yeah, it was really fun to make this project. It's almost done now. I guess these things are like the big things that are left right now. This one should be very simple because we have all the things we need for it. This one though is gonna be a big thing, I think, that we're gonna have to deal with. We're probably only gonna have like a subset of features with like Bash. I think you can like create new pipes and like redirect to those and stuff. I'm not sure if we're gonna have that. I think we're just gonna have what I deem is good to have at minimum is like redirect to files, output to files. That is probably gonna be the only thing you can do. I'm not even sure if we're gonna be able to redirect standard out, as like differentiate standard out standard error, but I mean that's very possible that we can implement that as well. But yeah, actually I'm gonna write this down. So redirect standard out, standard error. I'm gonna say separately. Is that how it's done? And then also redirect to files, to file. I guess it's like redirect and and append. Redirect to file. I'm gonna have two different things here. So append mode and I guess replace. I'm not sure what it's called. And these things are gonna be MVP. I don't think these ones are. I'm gonna mark them as not MVP for now. But they might be like nice to have. It depends on how easy it will be to actually do that right now, because we're messing with these things right now. And okay, so the AI is done. I'm just gonna go through. I think that's it actually. Yeah. Also, this is like a bug, but I will probably not care about this right now for MVP. We'll see. This might actually work now. I don't think it does, but we've done a bunch of changes since last time. Okay, so let's see what AI does. So the AI right now is working on like merging standard out to standard error when we are calling processes and storing the results. Okay, so it was broken by the AI change here. So now uses reader streaming. Okay. There are no more like close for minimize drain. Okay. The chunked reader still preserves line chunk boundaries instead of okay. Cool. Verification. This prints high. This prints the expected output. Also changed with this. Still is BDAC will bash 2 to 1 gives ABCD. Okay. Yeah, so that is kind of the this is the kind of behavior that you would want. Like you would probably just merge them through, I don't know, the operating system or something, and then read from that result. Because yeah, it's like right now the way we're reading from the output of the execution is like, it's very race condition, I guess. Yo Piano, welcome back. Thank you. How's it going? I mean, sure, whatever. It doesn't really matter that much. The way it works right now is we're trying to chunk error and output, and if there's like a new line, you could get some output from the other stream as well. So we're trying to interleave them in like a most sensible way, I guess. Part is not a simple bug and was a model limitation. We're still capturing standard out and standard out, two separate OS pipes and trying to merge it. Yeah. So we probably wanna like merge the pipes somehow using OS or something, so that it doesn't rely on some kind of weird race condition. So we get the same behavior as bash. It's going very well. Oh, nice. What are you up to? Once that child has written 2 different bytes, the resect writer is no longer recoverable from the user space in all cases. A chunked polar can approximate a byte into leaving, but it cannot be fully equivalent to bash, which merges the file descriptor level before the writes happen. Yeah, exactly. So maybe I'll check how bash actually does this in the source code, because it's like it's doing some kind of magic thing here to actually make this happen. So the current state is no output regression is fixed. Bash consists of merge ordering still not solvable with existing separate standard. Yeah, if you want exact behavior, next resolution is redesign. So we probably don't really need exact behavior right now. I'm gonna be happy with what we have right now. Either run commands through an interposer that tease writes into separate and merge streams at the source. I mean, yeah. The thing is, like, we want to be able to capture both standard out and standard error and have them separate. Also, but also merged. It's like we want all of that. Which we have now. We have like a merged that merges everything. You can sort out standard error after the fact, after we've like executed the thing. So you don't need to like or redirect something to something else first. You can just run the process and it will give you everything out. Hello Blue, what's up? Welcome back. How's it going? Alright, Piano still learning Python. Level is increasing perfectly. Wow. It's going as good as it can. It can't get any better. Or it can't go any better. That's awesome. Or add a dedicated process I/O multiplexer that owns both FDs and emits the merge stream as a first-class capture instead of reconstructed later. So I mean, this still feels like it's different though. Like it still feels like this could be race conditioning, because depending on when this is called, like, or how often this is called, the buffers could be different and the chunks could be different. I guess it doesn't really matter that much. Maybe there's inconsistencies there anyway. Like 2 bash processors might not even have the same output from the same thing there. Okay, anyway, great. So that seems to work now. I'm gonna check this. So Runic MVP. So that actually, okay. So here you can see if we go to MVP. So here's like the thing here. So the thing we're talking about, like the thing where the AI fixed here. So basically, we call a process. In this case, it's bash. So we're calling like this random bash script or bash command here. So first you have like printf out. That will put out to standard out, right? And then it's gonna do to excuse me. Which should put, so we should get like out and then but it goes to standard and then after goes to standard out. So we should get like the merged output should be out and then and then after, because that's how bash is doing it. However, if we run this, and then you can see also that we can actually access standard out or standard like this right now. But we can also access the merged output just by interpolating here. I'm doing great. I'm just trying to get this working here. And here you can see that we get actually out and then after and then probably because this is like read in like a one giant chunk and then this is read. So it's like, I think it's yeah, it's probably because this just outputs it outputs this and that, and by the time we read from standard out from this whole process, both of these are already like they have already outputted, so we're just reading everything there. If you would do this in bash, you can see it's gonna be different. So if we do this, whoops, actually, there we go. Here you can see how we want it to be, like out and then and then after, right? Hello M7MB6669. What's up? Can you help me, please? Sorry for interrupting. What are you? What do you want to have? What can I help you with? Yeah, no problem. All right. So, having an issue related to Twitch. Okay, what's the issue? Standard. All right, so that is now fixed. Very good. Okay, let's look for things that are not done and are not MVP, which is basically these things right here. So I think when those are done, MVP is actually done, except for these two. But this and this, then we're done. That's gonna be great. So, and then a little bit of, I guess we'll do a little bit of cleanup as well. Should we? Listen, M7MD, like, why do you think that I can help you with this? It feels like you should ask Twitch support. I'm not sure what that is, or like what you're talking about. You're giving me like major bot vibes right now. Anyway, so this (2FA) code. I mean, I don't even know what that is. Oh, two-factor authentication. Oh, okay, I see. You can't receive the code. I mean, how? I'm not like. I mean, you should bother. You can bother, but you don't. You have to bother the correct person. Like, contact Twitch support. Like, I can't really help you with that. That's like Twitch stuff. I hope it. Yeah. I hope you can get it working. Okay, so okay, let's just think about this one. What I'm gonna do is I'm gonna task AI with figuring out redirection. So this is I'm just gonna tell AI to, hey, could you investigate this to find a solution and give me a summary of what you find. So line 84 outline functionality I would like to have in the MVP version. Okay, and here's like where you have to be, you know, careful, because it's not really that much information here, and AI might fill in, especially codecs, because it doesn't really ask you questions. It does sometimes, actually. It has started to do that a little bit, but it mostly tries to run things on its own. So if you ask it, like, there's not much information here, and so it will try to figure it out on its own, and so you have to guide it a little bit, because otherwise, you know, it might do some weird stuff. So, and it might not even understand what redirections are. So I'm gonna give it like a bash example, I think. Redirections are or should work in a similar way that bash does it. And then I'm gonna just have like a bash C. Or actually, we don't even need this. Let's just do echo hello into file.txt. This should output. This should replace the file.txt with the output from the process from echo hello. This actually, I just thought of something. What if you had like echo hello and then cat into file.txt? So I mean, yeah, I just thinking about the precedence here, because technically, like, what if you put 2 into file, and then what if echo does, like, what if echo outputs to standard error? I think when you pipe, it only pipes. Wait, I'm actually not sure. Does it pipe standard error as well? Not sure actually. We'll just do it like this, and we'll figure it out. So this should replace the file.txt with the output from echo hello. There should also be the append mode echo hello append file.txt, which should append to the file.txt instead. Give me some suggestions on how to implement this feature. Do not change any code for now. All right, so it's gonna go ahead and figure that out. And in the meantime, we could try to figure out this one, because that is way simpler, I think. But it does require a little bit of tricky stuff. So first of all, let's see if first of all, it's like the symbols. Do we actually have these in the parser? So I will do logical. Oh, we already had logical. Okay, so I guess we already have it. But the thing is, we have it, but we don't. Wait, why is this not outputting anything now? Did pipelines break? No. Okay, so for some reason this broke now. Also, I think we can do this. No. Why is it breaking? Is it just... So that is not breaking. However, if we put this in a block, it's okay. So AI messed something else, because this did work before. So, right, and this is what could happen as well. AI goes in, and it's like, yeah, I got this, and oh, of course, the issue is this, and it's like doing a bunch of shit. And then we go back, and it's like, okay, well, now we're running the test suite, and this now broke. So it's like, okay. Of course, it doesn't actually know that we have a test suite. We don't even have, well, we do have an agents MD, but I think this is like horribly outdated. Yeah. Which is bad, I guess, because we don't want AI to do some weird stuff. So I'm gonna do new here, and then we're gonna do some recent changes broke runic logical could you investigate into this issue and suggest a solution? Do not change any code for now. Okay, well, anyway, while it's doing that as well, we can solve this. So we'll go back and look at I saw the other AI task was done, so it actually gave us an answer there. But I'm just gonna do this now. So logical 2. So basically, what I want to have is that, well, in Bash, you could say, you know, if you spawn a process, and after that you could do well, actually, let's open Bash. So echo hello. Of course, this just gets you hello here, and then we echo question, like $?? That's the same as saying like, okay, what's the latest, the last kind of process that was called through Bash, so this one, what was the exit code of that? That is what we're looking at here. This is the exit code of the last like thing we executed in Bash. And you can see it's 0, which means success. So that means, basically it means true as well. Because what you could do is you could say if, and I believe, okay, this is why I want to make Runic, because I can never remember how this works now. So can you do you have to have like double for this? Like you do equals 0, then yes, else no. Okay, so that is a yes. What if we change it to like 1? That's no. Okay, so that's kind of, you could use this to check like what was the exit code of the last, you know, last thing. Now if we said something like this flag is invalid, now will this report an error? So of course we will see the error message here, and then we see no. So that is basically something was went wrong here. But if we just said, yeah, so this failed, so that's good. Now what I also want to do is, you know, this thing. So let's say this fails, grep failed, right? So this operator will check if this succeeded. If it succeeded, we don't actually run this here. But if it failed, we do run this here. So it's kind of like, I mean, it's an OR. It's like a short circuit OR, but it's looking at the exit codes. And so here we can see the grep failed. I'm gonna change this to command failed here. Okay, if we change this to and, it will not run this, so it's like the other way around. But if we do some, you know, something that will succeed, then we get both of these. And if we do the other way around, so we do or, now we only get hello. So that is the operator that I want to fix. Now the operator is already implemented, and it does work for Boolean values, like the literal Boolean values, but it's but it doesn't work for exit codes yet. So that's what I want to fix here. Hello, not Yoshi's. Welcome, welcome. Metallics, welcome back. How's it going? It's going great, man. Yeah, I've been using like AI to actually do a lot of work right now in Runic, because I was like, whatever. I just want to get this done. Because I've been actually thinking about the game a little bit. My Metrovania game. I got a little bit of inspiration to continue working on it actually. So I wanted to kind of finish this and start up that work again. It's gonna be interesting. So yeah, so let's see. Okay. So AI is working now on another bug that it introduced from some implementation that it did, and the bug was this here, which this file hangs, which it didn't do before. So something the AI did made this hang here. I just have a weird feeling that AI is gonna play whack-a-mole here with bugs a little bit, but we'll see. I reproduced the regression as a hang, not a wrong Boolean result. Does not terminate the local state while minimal Boolean interpolation still works. It's not, well, it's not the Boolean that's the issue. It's the block. When you have a block and a process in the block, and then you pipe the block into another process, that's where the issue is. The logical path is fine. The break is more likely in the pipeline shutdown. Ends with that. The column waits forever. If standard in never gets end of file. The strong suspect. No, the older logic was removed. The current if. Yeah, so that's probably why it broke, because AI was like, "Hey, we don't need this," and it just threw it out, and it broke something else. That matters because the stream forward checks to hand remove closed source, and the channel powers no longer reports so closed. The downstream, yeah. Secondary suspect is the custom stream rewrite in process, but that looks more like a contributing change than the root cause symptom matches missing close propagation. Suggested fix: restore the previous pull edge up hang up based closure detection. If you want a new reader behavior, keep it, but also make crossfire state blah blah blah. All right, so. Man, I'm torn now, because I really want to just ask it, hey, could you just implement this then? But then it's probably gonna break something else. Using AI as a double-edged sword, yeah. It produces code, it kind of works, but at some point you understand there are some bugs and it's kind of tricky to find it because you don't fully understand the code. Yeah, that's also true. Like, if you use AI too much, you get like disconnected from the code. It produces code, yeah. So, but also, if you have kind of code that is like kind of tricky, or tricky, I mean badly written, and you have all these weird edge case fixes that kind of that looks like almost that they're not supposed to be there, but they are there because we want the behavior to work in a certain way, but the AI doesn't understand that. Well, I could have added like comments to a greater extent, I guess. But now we've run into this issue where it's like, hey, you don't need this, and it's like, well, it was there for a reason, and now you threw it out, and now we broke this. Now. Yeah, and I don't really have a good idea if this is actually a good fix or not that the AI is actually suggesting. So it's basically, hey, yeah, revert some stuff, okay, but then that should break something else because it was there, it was like implemented for a reason, I guess. If you want a newer, okay, so I'm gonna do this. Before we make any changes, please update agents MD to say that after we've done changes, run a test suite to check if there are any issues with the recent implementation. If there are, try to fix those issues as well. All right. The test suite could probably just could be based on MVP.rn, but more catered towards testing all different combinations of features, such as this example with a block that pipes into something else. Please create this test suite file .rm and update agents MD accordingly. All right, so it's gonna do that before we get to fix this issue. Now back to this one. So I want to have the same behavior. So basically we look at logical to bash. So we have like this command succeeded, command failed, right. So if you run this, also I want to remove the error messages here. All right, so we got like echo hello, command succeeded, echo hello, command failed. Oh yeah, okay. So it didn't actually. I'm gonna do this also. Echo test, grep test, so we can see the both things here. So echo test, we have echo from here, command succeeded, yes, echo didn't fail, and then we get grep test, which has an invalid flag, so it doesn't succeed, it fails, so it goes into the fail thing. Yeah, not the best example here, but I just want to show this is the kind of behavior that we want to have. Do you use unit tests? I tried it, but it kind of adds additional friction. Yes, I mean that is a price you have to pay if you want to have unit tests, and I would say it's not always necessary. You know, especially maybe when you want to have more velocity, like in the beginning of a project where you don't really know how it's gonna work. It's probably not great to start out with writing a bunch of tests. That feels like very slow to me. I mean, I know that some people swear by test-driven development, where you actually create the tests first before you do any implementation. But I just feel like, well, if you want to make like a new project, I mean, I feel like that works when you already have a project and you want to extend it with some kind of functionality, then that could work. I mean, yeah, so for me it depends on the use case and what you want to do. And unit tests also, like, to me, aren't like super necessary unless you have code that is like beginning to get a little bit complicated. Let's say you want to make like a library, for example, then it would be good to have unit tests, because you want to make sure that your library functions are still working, you know. And it's also nice when you have unit tests because well, good unit tests anyway, because then you're not as afraid to, or some kind of test suite, I mean, yeah, unit tests of course, that you can run to see that everything still works as it should. So if you want to implement something new, you don't have to worry about breaking a bunch of other stuff without knowing. So that's the thing, that's the key. Like, you know that now we know that we've broke something else because we had tests for it. So that is that's a good thing, I think, especially when you have like a library or something that is like a little bit more complicated, that you just can't. If you just have like, I mean, also it depends on if you're doing some kind of business logic that you wanna make sure that, hey, we need to know that this actually does work the way we want it to work. Then also you have unit tests. But some people are like very adamant about adding, like having like 100% unit tests, are like, that's impossible and bad, I would say. But also some people say like 80%, you know, unit tests. That's also like, I feel like people should decide, like developers should decide, like, okay, does this actually need unit tests or not? Because it is like extra work and it takes more time, and it might actually not even give you anything. I mean, I've seen tests for other tests as well. Tests to make sure the tests are created correctly. Because sometimes you have code that creates that like populates test data and stuff. So it becomes a little bit ridiculous. If you're implementing a C compiler where test first makes some sense. Yeah, I mean, yeah, exactly. It depends on the use case. You know, I don't think you can ever say anything that is like, always do this or always do that. It's always depending on the use case. It's always depending on, like, you know, I always have example folders, and what I usually do is run each example and all works in a final breakdown. Yeah, exactly. I mean, that is a test suite. I mean, that is that's sort of the same thing as unit tests. It's just that unit tests are just a specific type of tests. It doesn't have to be, you know, tied to a test harness, like a test framework or anything like that. It's just that you have to run some code to see that the thing still works as intended. Alright, so let's see. Update agents that require post-change regression paths include... Okay, feature combinations. Okay, so it actually used like this test folder, which I haven't used at all, basically, since this project started. So that is also a little bit concerning. Like, there's like old code still left in the thing that is not actually used. And AI actually was confused at one point, where it started to implement in like a deprecated area, which is understandable because there's nothing saying it's deprecated. It's just my personal knowledge that, hey, this, you shouldn't be here because this is deprecated. We're using this now instead. So you have to be careful. It's not gonna also exhaust every possibility and I'd choose the correct one, obviously, because then it wouldn't have done that. But okay, so we got this feature combinations, also added test suite. Okay, the new suite is output driven, similar in spirit to MVP, and covers grouped block capture, logic implementation inside. Okay, so it had like a whole bunch of stuff. So actually, okay, so it's like focusing on combining feature. I mean, that's not really what I intended to have. I basically just wanted one big test suite that it should just check everything, basically. But okay, whatever. It's checking some stuff. Like, I want for also, like, you know, every feature, like for loops, functions, nested blocks, like, yeah. Okay, so that it passed. I mean, it outputted stuff. I mean, yeah, and it didn't hang, so I guess that's great. Okay, well, anyway, because there are things in here, tests, features, that doesn't actually work yet. Like, it's not even implemented. Like promises, like we don't have promises. We don't have error types. Like nothing in here is gonna work. So, okay. So, yeah, this is just a mess right now. Okay, so let's... I want to check now then. Run the whole is... okay. Actually, okay, let's just tell this guy here. So the tests in tests features are actually old remnants from when the project started, and not all files in there are actually fully supported yet by Runic, the Runic runtime. So, or yeah, whatever. So let's just start with having a curated list of tests, or we create a new directory with tests. Wait, actually, so let's actually remove all files in there and create new one which fit the current level of implementation. All right, let's see if we can figure that out. Yo, what's up? What's up? Just wanted to ask, how do you convert the input you take from a user to an integer? Because I tried it and it gave errors. So first you get it, you get it as a string, right? And then you can use parse int from standard format. So we have the input here. So basically here you have the input. You have something like this. Oops. No, sig run. Okay, this just does this. But let's say you wanna say we're gonna do like a number, and we're gonna say standard format parse int, and let's just do like a, I don't know, u32, whatever. So you have that, and then you pass the string, and then the base, and there you go. So there's the thing. However, it can return a parse int error, so I'm gonna catch that, and in that case I will say, well, actually I will catch and just have a null. So now this is like an optional u32. Okay, so it's like if parseInt fails, we get null. If it succeeds, we get a number, right? And then let's do like, you inputted this, and I will do like, actually I'll just say like, if we have a number, you inputted that, which is a number. Okay. So you have this if here on an optional. You can capture the value out and use it here. So this is how you would do it. And now if we run this, it fails. Right, so okay, yeah, the formatting, I have to remove the formatter there because now it's a number, not a string. Okay, so if you put a string, it just says this. If you put a, you know, a number, it detects that it's a number. And if I wanted to take input again, I would just write the input line again, right? Or I would empty the buffer setting. So yeah, so this input here is like it's taken from the reader, the file reader here, which is like it's stored in this buffer here. So so you don't I don't think you really don't need to worry about where this is stored or anything. You can just say, like, if you say the var input, so now it's mutable, so now we can reuse it, and then you can just say input equals take a delimiter exclusive again, and let's say we just copy this. I'm just gonna copy this logic here. Okay, then you can just do this again to take until delimiter exclusive here, and this should now be doing to. Oh yeah, so the type doesn't need to be there. So now it's like hello 42. So now it's doing it again. So you don't need to empty the buffer or anything. The reader will handle the buffer, like it handles it. It's basically using the buffer as a space to where to put the data that we read. And of course, yeah, and then this would, like, of course, if it exceeds the buffer, then there's you can do some kind of you know, streaming thing, of course. But you know, if you're working with smallish strings, this should suffice pretty well. Thanks. I was trying to code something yesterday, but these input errors were so much. I mean, yeah, I wouldn't actually recommend trying to program in Zig if it's like one of your first languages, or if you're, or rather also like if you're not used to low-level programming. I mean, right, and the reason is because Zig right now doesn't really have a lot of documentation. You could, although you could go to the Discord, the Zig Discord, and ask for help there, because there's a very helpful like forum there that's called like, or like a, I don't know what it's called, a post. You can post like questions in Zig help, Zig help channel thing, and people will help you if you have questions there. So that's also a tip for new people to Zig. But as I said, like Zig is not like an easy language to get into if you're not used to programming in general or low-level programming. But you know, if you got a little bit of experience, I would recommend it. Okay, so logical, yeah. Let's see what AI has to say here. I don't really remember what we said. Oh yeah, the tests. Replaced all test feature remnants, single current time regressions, runtime regression. Okay. And rewrote this to reflect. Great. This is what AI is pretty good at, like rewrite, like documentation. Like, I mean, I don't love all documentation that, you know, AI puts out. I love documentation that is like terse, short, descriptive, get to the point, and maybe expands where you need it to expand. But I usually don't like when it just, you know, puts out a whole bunch of text that is just like, well, I don't really want to read all this, you know. But yeah, it's pretty good at changing existing documentation, just update that, and also like search for a lot of places to change things all at once. I removed all aspirational feature files and leftover testable content, new suites, output during the colors, commands, conditionals, loops, functions, everything. Great. Okay. Wait, runtime regression. So is that like one file to rule them all, or? Okay, I guess, yeah. Cool. Great. Now let's get back to... Oh shit, now I think it like disappeared. This one maybe. Okay, so actually this was for redirections, yeah. I wanted to do back to the... Wait, did it actually work now, or block capture? Does this work now? No, it doesn't. Still doesn't work. Okay, back to the issue with running higher logic code. It still hangs. What was your suggestion for solving the issue? All right. Restore that. Keep newer stream code if you want, but don't rely on it for alone for lifecycle state. The close state should be explicit. Add a regression route for the X shape. Yeah. Okay, let's do it. All right. Okay, let's see if we can. No. Do this here. So I want this to work the same, of course. Oh, but we don't have like redirect, so I guess we'll remove that for now. We could also call bash, I guess. No, because that's not gonna... Actually, you know what? What is the exit code of bash? Like when you... If you run a process that fails in bash, and that's like the only thing. Okay. Okay, interesting. So bash actually exits with an exit code. Is it the same exit code? Yes. Okay, cool. So then we could actually do like bash this instead. And we'll redirect here because we don't have redirect yet. So now if we run that, we should see, well, we get an error because it's not supported. But the idea is that these would output the same thing. Okay, but now we need this back. Bash. Yeah. Okay, let's see what you're doing. You're still doing this. All right. So what do we need for this to work? Because we already have like these binary expressions. The only thing we need to support is being able to compare or like implement the binary expression for this specific setup here, where you have like a process on either end. So actually, it's kind of bad right now. We don't actually want to change the compiler right now because the AI is doing stuff. Probably. So yeah, so what we need to do is we kind of, I think if we just support the case where both of them are processes, that will kind of, it's kind of like an if here. If this is success, then we do this. And this is the other way around. If this is not success, then we do this. So we kind of already have the mechanical parts to put this together already done. It's just that we need to make it work. Okay, there we go. Fix the hang had two causes. No reporting close on poll H up. Yes. Non-final pipeline stages started there. Standing out forming helper too late for a group block. Inner commands would block. Could block waiting before anything drained their output. Yeah, so there was a kind of weird race condition there. Keep open true to close destination when a source finished, which caused the group block stage to later drop later lines. Oh, I changed those 3 spots and added a group block pipeline case. Awesome. So now apparently this should work. If we just run the MVP now, it seems to be good. We also have check MVP. So this is like, this was the first kind of real script that I made in Runic, which is running both like MVP bash, the bash version of MVP file, and the Runic enable IR is no longer a thing. Actually, yeah, I forgot to mention, I actually merged in the IR changes, so now Runic has the IR is now default and the old interpreter is deleted. So because we caught up with the changes in the IR branch, so that is now merged. I'm working directly with Moss with our main now. If we run this, they are not the same. Okay. So what is the difference? So if they're not the same, it should show like some kind of difference here, but I'm not sure why that's not happening. It's like they're not the same. Okay, so then we look at the log files. We store this in the log files. We run those commands. Yeah, we store, basically here is storing the results in files. It's kind of like redirect. And then, except we're using like bash, we're using like a workaround because we don't have it yet. And then we run diff on the files, and then we remove them. Let's actually not remove them, because now we can check them. So mvp bash. Oop. Loading. And then like, I don't know what C means. I think it's like a format. Okay. I see. I think we'll remove this merge thing. Yeah. This thing I'll remove. It's like the MVP is not really a test suite to check if it's working like bash. It's more like these are kind of the basic features that when these are done, the language is done. That was the idea of this. Now this should work. Yeah. There we go. So it does work. It was just that they... Okay, so now I'll remove bash and okay. So yeah, so that works. And if we go back to logical, so this should work now. There we go. So as you can see, the logical stuff, it still works. It's just that we have to support like executions there. So logical 2. Yeah, sorry with that. I mean, I didn't mean to like put you down or anything before. I was just that's just usually what I say with people. Like, of course, if you want to learn Zig, go right ahead. Like, there's nothing wrong with that. There's nothing stopping you from that. I was thinking more like, I wouldn't suggest to people who are new to programming languages, I wouldn't suggest to like have Zig as a first language. I would say like Python is probably the best choice right now. Probably. Or one of the best choices anyway. Just because I think it's better if you have an easier language to start with, because then you can focus on learning like basic programming concepts to understand how to actually break problems down into smaller parts and figure out how to solve problems, while you don't have to worry about things like memory and types and classes and all this crap that comes later. That was my idea with that. So didn't mean to like put your Zig journey down or anything like that. I'm sorry if it came across like that. Okay. Okay, so we need to make this work. All right, so now we go to the compiler, and we'll go to compile binary, and here's logical and logical OR, and so this one, this is like the comp time known. Like if the left hand side is comp time known, or if the if the left hand side is comp time known, that basically means the right hand side is well, yeah. So if the left hand side is comp time known, that means that kind of we know what to do with the right hand side. And so the left, so, or, well, if we have a comp time known result of this logical, we can look at the result directly. And it's like, okay, well, it's either going to be left or right. What does that mean? Well, left means that the result of the logical evaluation would be the left hand side. That would be like the result of the whole expression. Or the right hand side. Now, if it's the left hand side, we have it compiled over here, and basically the left hand side we always need to compile, but it could be comp time known, which means it doesn't actually become any instructions or anything. But the right hand side might have side effects, or I mean it might have like instructions, but we don't even need to compile it if the left hand side, let's say you have like, you know, let's say you have true or echo hello. So, you know, this doesn't even need to be compiled because we already know that we already have true here. So we don't even care about this right hand side. So that basically gets thrown away. We don't even compile it. However, if we need if it's like this instead, which means we get a right here, then we compile the right hand side. So that's just a little bit of optimization that we have there for comp time stuff. So that's what's happening here. It's basically just checking, do we have a comp time result or not? If we do, then we can handle that. It will be pretty simple to implement there actually. Okay, but otherwise, we will continue down here. So we have both left hand side, right hand side. Now it's a runtime known result. So we have to compile both sides to be able to select which one is going to be the correct one. And we have a ref for this result that we return. Interesting. Okay, I guess that's usually how it's done. It's just normally we don't actually create new refs and return those. We usually return like a register instead. So this is kind of strange why it's doing it like this, or why I decided to do it like this, because yeah, they are, I mean, yeah, because it's easily then that the we have unbalanced stack from that. I wonder if you have like a lot of these, how that's gonna work out, but okay. Anyway, so we create a ref that we store the result in. That's what we return. Excuse me. And then we add an instruction which is the log. That stands for logical, so that's a logical operation. It's a binary operation with the logical operator, and it's basically just left and right. And then the the evaluator actually needs to work this out to understand what's going to happen. So we have the logical, and we have like left, excuse me. So we have the logical. Now left and right should already be like compiled. Maybe that's also an issue actually. Because what if it is, you know, grep invalid flag or and echo hello. You know, this is compiled here, and then this is also compiled down here. So they are compiled like back to back. But this shouldn't actually execute unless this is done. So basically this is wrong here. We can't just compile the right hand side directly. We have to have like an if here, basically. We almost have to convert this. We could convert it into an if expression instead that basically is doing the same thing, and then we just evaluate that as instead. It's just that the if also now the condition have to work then. Also, does the if statement actually result in anything? Because that is also very important if you want to store this value somewhere. Like, I'm not sure exactly what this is gonna store, especially if it's like a no else. I guess this just returns the compile expression. Wait, here we have like condition sources value tag exit code. Yeah, because that's the boolean, right? Oh, this is also com time. Yeah, if the source is com time known, we do this, right? So we return the then expression. Wait, no, this is else. Oh, if C is true, we return the then expression. If it's false, we look at the else branch. We could either just have an expression, which we just return that, or recompile nested here, or recursive. Otherwise, now we're in runtime land. So what would be the results? We pop sort. No, we pop. What do we pop? This one, the result, right? Right. And then we set the result to either then or else, depending on which one did. So what I'm examining here is that if our if expression actually, like the result of the if is actually kind of like a ternary, where you have the value in the then expression is, you know, the result of the expression if that branch was executed. So if true, then you would have the then branch be the result of the entire expression, which could be a value that would be bound then to a variable. So we would need, so that's good. I'm just wondering about the no else. I mean, that would probably be a void. No else. This is interesting though. I guess it kind of makes sense. Well, if it's true, then it was okay. So if it's comtime on true, then the expression result is the then expression. Otherwise, we have a void value, which kind of makes sense. Otherwise, we don't really have a result. Actually, we just return void, which does not actually comply here, really. We should, like, if the result is true, we should get the then expression. But, yeah. It's also interesting. I want to see, what if we go to logical and bash version? I want to see, let's say you have a variable So echo hello. Wait, what did I think about? Like as I'm typing it, it feels like if we just do this, you know, it's obvious that what's gonna be the result. It's basically just gonna be hello. If we run this, it's gonna be hello, command succeeded. What was it that I was trying to test? I don't know. No, okay, basically, okay, this is kind of weird and different. I think this is gonna be different for Runic actually. Maybe. I'm not sure, because this is kind of like, hey, yeah, we're binding to like an entire like command expression here. While in Runic, it would be more like either you get the left-hand side or the right-hand side. Then that is not correct. That is not. No, I think what's gonna happen is that we bind X to its own thing. It's gonna run this command as well, and then just you know, it's gonna be. It's not like we get either left hand side or right hand side, because we're binding. We get a whole, like it's gotta be an execution result instead. Yeah. I don't think this no else matters in this case. It's always going to be if else, I think. Let's see. But I think the left hand side should always be compiled. But then the right hand side, it depends. Like yeah, and then right hand side is going to be wrapped in an if. If we know that the left hand side is true, we can just compile it directly. I think we need to get like expression effects here. Oh, right. So if, oops, no, god damn it. If we need capture, then if we need capture, I have to think about this. Actually, does it matter? Yeah, sure. Let's just do it if it needs capture. If it doesn't need capture, maybe we don't even need to compile it differently. Because if there's other side effects on the right hand side, we don't want them to execute either. But this should this is basically like has side effects right now. So if this is true, I'm just gonna do this. I'll just do this. So we have two entirely separate branches. Although this part could probably just be done directly here. Yeah, for an early exit. But then if we need capture, we do something else, we do this. So I think we want to do an if statement, if else, so this is the if expression, and then we have the else branch. And I think we return that. Yeah, because then we don't really do like a logical operation like this anymore. What we do is we basically just have an if else. It's, yeah, interesting. So we have condition capture, blah 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 blah. Why can't I repeat that? Okay. Oops. Condition capture. Capture is probably, I don't know. Let's put null here. Then we have then, and we have else. We don't really need to worry about else because we already have else. Like, we're not using if, the else from if expression. So we can just pass null there. Span is, I mean, it's gonna be binary span. Condition, I guess that's gonna be like left. Actually, no, it's an expression. It's already compiled. Huh. Okay, maybe we just need like a subset of this then. Or we just say, let's not compile. until we know we can use if else. So actually let's just move this here. Okay, and the condition is binary left. Because either it's gonna be, you know, true or false. It's gonna be some kind of Boolean expression. Well, or exit code, that's the thing. Then expression is just gonna be binary right. Which kind of also means that left will be compiled, and then the right hand side is only going, we're only going in there if it's true. But the else branch is also, we need to figure out. So that's a union enum. It's either an expression or another if, but it's not going to be an if, it's going to be an expression. So what will happen if if we don't go into the thing? I guess this would be like an empty thing. It won't really do anything. But what would the result be? I guess it wouldn't be any result. I'm not sure. This is kind of weird. Because what... Wait. So if... So we have like if echo hello, then echo command succeeded. Like this would be the equivalent. And you could also write this code here and have it work. And then if, and then we have like, you know, a negation here. I don't think we even have negation actually. Oh shit, maybe that's also gonna be something we want to add. Well, let's just say we have it negation. Then it's gonna be like that. But it's like, what happens in the else case? Let's say this is example 1, this is example 2. And then if you use, let's say you want to use so the issue here is like we bind this to a result. So this result is basically capturing this as a command being run. What would the exit code be of this? that is the question as well. What would the result be of this expression? Because it's like, it's obvious if this is true, then the result should be the thing inside here. That should be the result. But what if it's false? What would the result be? Should it be a success? I mean, I guess. What about this? I guess it's like a, I guess we could just say like it's a Boolean success or something. If we go into the else. But then what? So that is probably for the and. Yeah, that's also another thing. This should only be for the and. If the operator is logical and, then this makes sense, sort of. Actually, no. If it's and, then both have to be succeeded to be true. If we go into else, that means that one was false, which means the result should be false, or it should be the exit code of the thing that failed. I think. Again, we can test with bash. So if we run echo hello and echo command succeeded, then obviously this would be true. If we had like grep command failed, should this also be true? Because this was the command that was like at the end. Okay, I would guess it's true as well. Yes. Okay, but what about and? Because then this fails and it short circuits out. So what is the exit code here? I'm gonna guess it's inheriting the exit code of grep. Okay, yeah, so that's correct. You see there's 2 here, which means that was the exit code of grep. So we actually grab the result of this one when it comes to the exit code. The thing is, I don't think we really have this. Yeah, see, the thing is, like, if this fails, the result should be the execution result of this process call. But there's no way of like getting that here, I guess. Well, maybe we need a special compilation of this if else here. Man, this was not as straightforward as I first thought it was gonna be. So this basically compiles that. We have the condition. We're checking if it's comp time known. That's fine. Otherwise, we have the result. Yeah, so the result is actually like if the thing is false, we get the else branch and we compile that expression. So this is the difference here, because we don't want to compile this expression. We just want to use the result that the condition was. What was the result of the condition? That's what we want to use, not like a new expression. So we basically want sort of exactly the same as this, but just a different version here. I mean, we could maybe like add a type of else here actually. That just says, yeah, just use the condition result. So I'm just gonna, well, yeah, so I'm just gonna say dot condition. And we'll go over here and we add this as an option. I guess it would need a span. The condition span should be the left, actually. Okay. And if it's condition here, we're in the else branch. Then we should just return condition actually. That's the result of the whole thing, yeah. And then here, it's a little bit different. Because the result is like empty. We can set the result to condition. However, the condition now is actually lost. That's the thing. I think that what we want to do is maybe store it after we have the result here. Like if else branch is equal to condition, then we do like a set result to be condition. Oops. Source. Actually, it's not from. So we do, so we kind of store condition in result as a temporary thing if we need it, because result is going to be overwritten by the actual thing later. But if this is condition, we are just gonna, we don't actually need, to do this. Well, we need this. I guess we don't need this. No, yeah. Okay, so we only need this if we go into either of these ones. Okay. Let's shuffle this around a bit. So, no, actually this would be like this. Otherwise, we actually don't really do anything here. If it's condition, it's already set to condition from above, so we just pop it and return that. Yeah. Okay. Okay. So I think we have support for that now. So basically, yeah, we say that we have the if else. If the else thing is like a condition, that means that if you go into the else branch, we should just use the condition as the, and as I'm saying this, it's like it sounds very convoluted, and it probably is. But basically, we want to use the condition as the value of the expression itself. But otherwise, we want to use the right hand side or the then expression. Okay. Now back to here. So that is for the and. What about for else? I'm just gonna do this very naively here. If binary operation is else, I mean that's the only thing it can be. So what's gonna happen then? Well, I mean it's the same thing except this would be, I mean, or logical or. I mean, if the operator is logical or instead of and, the condition, I think the condition is flipped. It's negated. It's like if this is false, then we go into the second branch. If it's true, we keep with this one. Yeah, so it's just negated. Which we don't have that expression. We don't have a negation expression, I don't think. Well, we have this one, but it's not used anywhere. We don't even, like, we don't have unary operators at all. I mean, I guess we could add. We could like add. We have we have a struct for it, but we don't really have like any implementation. Operand expression, right? Span. Okay. I mean, we could add like internal support for unary expression, but we don't have we don't have like parsing support for it. Okay, so I mean, I guess we'll make a new unary here. So we'll just do negated Wait.
Oh, there we go.
Alright, so the operand is gonna be logical not, or the operator, I mean, and the operand is gonna be binary left, and span is, I guess, we'll just inherit that, or maybe even the whole binary thing. Whatever, it doesn't matter. Okay, so that is that. We create the thing. And this will be negated. I'm gonna call it left negated. Yeah, I think that's it actually. Like that is the only thing that's happening. Like if it's a logic, if it's the other thing, we actually just use the negated thing. So what we could do is we can merge these two branches. We can say so left resolved, I guess, is gonna be if binary operator equals logical and it's gonna be binary left, else it's gonna be this thing. I'm just gonna do it very ugly here, but basically, and then break negated. There we go. So then we can remove the U and U and U and U and U are resolved. Alright. So if binary operator is AND, we just use the left hand side directly. Otherwise, we create a negated expression where we just negate the left hand side, and that's the result. So that's left resolved. Then we use the same logic here to compile if else with left resolved. And yeah. Okay, so what's your issue? Switch must handle all possibilities. Run script. Type checker. Oh, populate if expression. I forgot what this was. Statement, expression, right? It's like an expression. It's like a walker. It walks along every expression. I forgot what we used it for. Okay, here we go. Now we get a bunch of errors. Analyze if expression is playing. Okay, so condition, nothing happens. Expected area diver void. Oh, switch must handle all possibilities. Render expression HD. I'm just gonna do some lazy stuff there. There we go. Actually, this won't really work because it has like an indentation. I think you have to write indent. All right. It's just for formatting the thing. Condition. What is this? Ah, the else branch, right. Yeah, we don't need to do anything there. Okay. There we go. So I think what happens now? So basically, I think this now is going to be called in these expressions, but we'll see. So logical to rn. Expression type unary not yet supported. Right. Right. Okay. So if we go to evaluator, of course we don't have unary here, but we can add it. Instruction type. No, it's the compiler. Yeah, compiler for unary. That's right. Which we don't have. So compile. I mean, I guess we could add like a unary here. Compile unary. Unary. Okay. We'll just change you to type. All right. Now, compile unary. So, I guess we'll switch on the operator. We have logical not. What else do we actually have? Is the question. Positive, negative, positive. Okay, this is the. I feel like the positive. This is like super. Is this it positive? Is the idea that this is the same as like abs? I don't really know, because this is very AI here. The positive, like I would never even think of having, you know, a positive unary operator. You know what? I'll just whatever. But I would remove it, but yeah, we don't even, you know, have these things. I'm just gonna remove both of those. So the only thing we have is a logical not. Okay, so how do we actually do that? Is the question. Should we just add? We could add a negate. Operation, like a negate instruction. So basically what we would do is we would get the value or result, I mean, and we will do compile expression unary operand, and then we would say negate result. Well, I guess we could also say like if this is an exit code, well, then it's like we know that it's like com time known. Yeah. So same like this. Then we could just return from value from boolean, and then result source value exit code to boolean and then negate that. Not. Wait, is it not? No, it's this. Right. Okay, then it's comp time known, so we just take the value that we got and we negate it, and that's it. I'm curious though, because yeah, this would kind of normalize the value as well. Like you could get like false, for example. False could be anything that's not 0. So if you get like a 2, how would actually bash do that? So it's like, let's do like bash, you know, if you do grep invalid flag, that is 2. What if you do not grep invalid flag? Wait. What did I do? Wait, do you have to do it like this? I don't know, man. Whatever. Hope I didn't do a lot of stuff. No. Okay. Right. So that would negate that. Otherwise, we would need an actual instruction to this, and this will probably be a location or something. Then. So yeah, this would be a location actually. So we're negating the location here. Okay. So let's go to instructions, and we need to add a new instruction type. Let's add it here called negate. Performs logical negation. Okay, oops. And I mean, it's a unary operation actually. So let's make a new thing for that. A unary operation. Yeah. So I mean, it's basically gonna be So we have operator type. That is going to be a unary operator. We have the operand. No. I mean, technically we could use a value, but it is probably always going to be a location. Now, where would the result be stored, though? That's also the thing. We could do like an in-location modification. No, that wouldn't be good. We need a new location to store it. Sure, why not? Okay. Yeah, and you don't have. Wait. Okay, let's just add it over here. Source operator is, wait, source location. No, it's not. We don't need operator. We need source location. Yeah, and then I'm just gonna say R as a location for the result. Actually, that could be in place, although if it's R, that doesn't really matter that much, I don't think. Whatever. We don't mess with this. We will say also we don't really do anything there. We just add an instruction which is negation operator. Wait, I did this wrong. You are a unary operator, but oh, I see. Let's just remove the operator part because we don't really have other operators for this one. It's like the operator is built into the instruction. It's like, hello, it's like Rust or more difficult to get it. I mean, I beg to differ. I don't get Rust, or okay, I tried Rust without like reading up on anything, like just a little bit. I didn't read up on anything of the on like the borrow checker rules and stuff like that. So basically, I couldn't do anything in Rust because I got yelled at by the compiler. But Zig, you know, you can. I mean, I don't know. I just felt like in Zig, I can try something and it works in the end. So there you go. No, but yeah, it's different for sure. Like I'm not I don't really know anything about Rust, so I can't really speak to anything there. But yeah, the syntax in Zig takes a little bit getting used to. That is for sure, and also the comp time stuff also takes a little bit getting used to. But then once you get it, it's really nice. Okay, so you need a location operand and result. Right, the operand is a location and result Are you a Rust developer? Amba. Alright, so that should add that instruction. Right, so let's say that we have to negate the location and then we need a result. That would be R then. You know what, we could actually just have this return the location that we're given, so this could just return results. I mean, that's fine, because now we can just return this. We don't have to write that twice there. Okay. Oh yeah, we need dot from as well. Okay. Location. Oh, I see. There's like a try that I don't. Oh, we need a try here now. There we go. Okay. Now we have a new type of instruction which is negate. So now we can actually add that in somewhere. I guess we can add it here. Okay. So we would get two locations. This is the one we want to look at. So we want to grab this result. So this would be the operand. Now, how do we get the value? I forget. I mean, we could do like resolve location. If we follow this thing, yeah, resolve location. So let's do that. Where are we actually? Here. So let's do resolve location. That's the location. There we go. Alright, so that is that. Now we have the value. It should be of the type exit code, although it could also be an execution result, in which case we need to coerce it into an exit code at this stage. So so that's the operand. And then let's say we have this thing. We also want to set location now. So we're going to set the result to be negated. But we don't have negated yet. But this would presumably set the thing there, which should be R at this point. But yeah, okay. And that's it. Then we return continue. Alright. Now, the only thing we need now is to negate it. So I think like we're gonna check, okay, well, are you an exit code? Let's just switch on you. Are you an exit code? Then we want to negate that. Maybe we just add a convenience here actually. Negate. And we return from boolean self to boolean negate. So negated is going to be that. Okay, but if it is something else, whoops, it's going to be something like it's going to be like an address. And then, if it's an address, we need to check if the type of this is going to be execution. Where is this thing? Results. Execution result type. It's not actually imported in here. I guess compiler. Wait, is that not on there? Execution result struct type. There we go. So if that is the execution result struct type, then we can get the exit code from the thing. Otherwise, this is gonna be kind of, I think this is like a compiler error or a runtime compiler error thing. I'm just gonna say unreachable here. Okay, now we need to get the exit code. What is this? Thread exit codes. Wait, we don't have thread. We have the closable. What? Wait, well, no. Actually, no, we have the exit code in the closable. Right. Yeah. Closable. Get closable. There we go. And that is, well, okay. The operand is that type. So we know that the struct is at this address on the heap. So to get closable, that's like 0, 1, 2, 3. So the handle is going to be at, so handle address is going to be the address plus 3. Now this is highly professional code here, and then we have to look into the heap. So that's going to be heap shared heap item, wait, values at wait, no, it's gonna be get handle address, because you are usize, yeah. So that is gonna be the close, so no, yes, no, that's gonna be the actual handle, which should exist. So I'm just gonna do this. It should also be a, what was it? I mean, it's a integer. Wait, I think it's a U integer or a closable. Actually, no, it's a closable. Yeah. So that's the handle, and then we paste that in there to get the closable out, and then now we have the result, which is the exit code. Boom. And then we return exit code negate. Wow, okay. This is a very iffy here. I'm gonna add a to-do here. Replace with proper struct field lookup. Alright. The rest is kind of fine for now. But really, yeah, it would be great to have this better. But yeah, this is now, we're getting to address plus 3, which is the closable on the struct type. We get the handle of the closable through the share for the heap of the, so we get the address at this on the heap to get the actual handle, and then we get the closable from the context. We get the exit code from the closable, and now we can do negate. Actually, return is not correct here. It should be like break here. There we go. Okay. If we get anything else, that's going to be unreachable. So it's only going to work for either literal exit codes or, yeah, resolved exit codes, or an address that points to this type here. And you are an exit code, so is there a from here? No, we can just do exit code. There we go. And that should be it, I think. I mean, yeah, we'll see if this actually works now. We can't really have a easy test for this. This is basically only, like, we don't have an actual operand we can use to test this. We just have in this case here where we actually run these things. So okay, I was suspecting that we would get an error. It would be a miracle if this actually worked the first time. Access of unifield exit code while field address is active. Right. Oh, it's in the if. Okay. So, okay. Actually, yeah. Okay. So I think I know what's going on. So when we compile the if statement and we supply an expression in the condition that is not an exit code directly, it doesn't actually handle that. Now I'm contemplating whether if we should coerce it, like we need to compile the whole expression, but then we need to coerce the actual value in the jump here condition. We have to coerce this into an exit code from an execution result. So we have to actually do that. So let's do like result condition. So we have to look at the type. If this is execution results type, we will have to. Is there like a field? Yeah, we can do. So this one actually does have get internal structure. I'm not sure if this is all AI. This function here I actually am made with AI. I made this with AI. Okay, so it basically just looks at the field, and I mean, wait, but this the size is always 1. Okay, or if we have a struct type. Oh, wow. Well, we don't really have nested struct. I mean, we don't have fields that are other structs. Interesting. I didn't actually think about this, but that is true. Okay. Okay, so we have this function that actually we could more easily get the struct field. I guess this. What do we actually get? We get internal struct field. We get an offset and a type expression for, I guess, the field. So I guess the offset would be. Wait. Well, how do we actually use this? Field dot offset add. Right. So we just use it like that. Right. Okay, let's just do this then. We'll break that. Okay, else. Hello, Samarth. Welcome back. Busy in my studies, that's why no time to see it live. Yeah. That's good that you are focusing on that. Hopefully we'll soon be done with Runic here. I am currently doing logical operator, logical operators for execution results, which was actually not as easy as I first thought. I thought it was gonna be a breeze. Turns out it was not. That whole thing has been, following me since the start of this project. Actually, it's always like, yeah, this should be easy, but then it's like, yeah, it was actually very difficult. A lot of things has been like that. All right, so anyway, now this is just condition. Otherwise, we're gonna have to get the field here. The struct type is execution result struct type. The field name is going to be exit code, or was it closable? I don't remember. Closable. Yeah. It would be nice to have that. supported by some kind of compilation as well, like the Zig compiler, to have it auto-completed. Okay, so there's our field. So what we need to do is we need to look at the condition, which is going to be some kind of location to a heap address, and then reach into that and then add. We basically just want to add 3. So we know that the condition is going to be that. So so it's going to be a pointer to the heap somehow. So if we then use, let's say we could use R2 maybe. Actually, it doesn't matter because this is jump. It only matters if condition itself is R. So we could use R2. So we'll set R2 to be condition dot source. All right. So R2 is now the pointer there, and then we just add the field to it. So we could use something like F here, where we add and then left. Actually, it could be add a sign. No, it's just add. And left is from location register R2. And right hand side is going to be from value from. Do we have like from integer or something? I don't think so. Field offset. We have bytes from address, from boolean, from integer. I'll just do this. That's fine. Just to ask, do you think AI will take jobs of corporate employees? Also has above average skills, not too high, but above average skills. They also lost job due to AI. Do you think? I mean, I think I don't know, man. I think that productivity has the potential to increase with AI as a tool, but right now we still need developers to make things work properly. And as long as you need developers, you also need junior developers to later be trained into senior developers, because the senior developers, they disappear because they get too old. So you always need a fresh supply of people that are currently learning the skill. So I don't see that it would. It's probably not over yet for us. I'm gonna say it like that, but you never know, I guess. The AI could all of a sudden it could just get even better, and then just now we don't really need anyone anymore. Everyone gets replaced. I don't know what's gonna happen, man. I think the best thing you could do is try to go with the flow and learn how to use AI as a tool right now. So that is the, I think, a good way to get into to it more is like learning how to use AI right now, because that is what we're trying to do in our company right now, and I think that is going to be a usual thing you do in the workplace. I know there's like contention between people who like to use AI and people who don't, I think, or contention between is maybe a strong word, but basically I don't know, I get both sides. Like, I get not wanting to use AI because I've been there as well, and I'm kind of floating between the two ideas, like not using AI, and then also, or just using AI for certain tasks, or mainly using AI for a project. Yeah, it's like a new shiny tool that you can use, that you have to learn first before it gets productive, because you can use it wrong and you can't use it for everything. So you have to learn it. It's gonna be like the new thing to learn and to know. And then I think everyone needs to have it in their, I don't know how it's gonna look, but you know, you're probably gonna be required to have some sort of AI knowledge or anything like in the future. Maybe we'll see. But you know, ordinary programmers are still needed, because AI cannot actually do anything, or AI can't do everything, so we still need programmers for now. Hello Joe, what's up? Welcome. Okay, so where are we now? We have this from integer, which we can use here. So we're basically just adding R2 with that, and then so that is pointer arithmetic basically, and then the result location is gonna be back into R2 again. Okay, so now R2 is pointing to the correct field, and then I want to break now from location. So what is condition? This is a result, yeah. So this is a result. So what we need is from location, and the location is init register R2. But then we also need to type this into wait, this isn't actually the exit code though. This is a, yeah. Okay, let's skip this actually. I think that it's fine if the condition is an execution result. We just need to support that in the runtime, like in the evaluator. Yeah, because I just realized that we don't actually have a way to like get the exit code out in the instructions. We actually have to, what we have is the like the process handle is what we have. We don't have a way to get the exit code from there, because that's kind of like internal virtual machine stuff here. So now nothing much. All right, are you interested in development? Okay, so jump. Oh man, time really flies. I have to go now soon here. Man, I just want to make this work. I thought this would be a quick detour, but it was really not. Okay, so right, so we're kind of here. I think we are assuming it's an exit code, which it could be something else. So what we're gonna do is we are going to say if is wait, this is an address. No, we're gonna say, well, if this so this will never be a literal, I don't think. It's always gonna be, wait, this is cond, right? Cond. This is always gonna be a location, I'm pretty sure. So we're just gonna assume that this is a location, and we're gonna check if this is type execution result type. Okay, if it is, we're gonna do something. Otherwise, we're gonna do this. Okay, so if it's this, then we need to grab the exit code the same way we did the other thing. So where's the negate? Yeah, we need to do all this thing here. Why though? Why what? Handley Thandle. Welcome, by the way. Actually, I've cleared the basics of C-lang properly. Now I'm thinking to go with backend plus Python. Do you think it's a good option in 2026? Tell me! Sure. Go for it. You know, it's not like you're making a decision that will that you will stick with for your entire life. Like, you know, you can learn multiple languages and multiple types of backends and front ends and whatever. All right, yeah, sure. Let's do the same thing here. All right, let's see. Yeah, that should be good. The address though is going to be wait, the address is just condition. No, it's the value dot address. Yeah, there we go. And then we have the exit code. And now once we have the exit code, we can check. Well, actually, that's gonna be the value. So I'm gonna say this is exit code. No, wait, we don't know if it's exit code or not. Whatever. Let's just duplicate this. But only if exit code to Boolean is true. Otherwise, it falls through there. Okay, so either we have this thing here, which means we need to coerce it, we need to fetch the exit code out, and then check the exit code. If it's true, then we jump. But only if... Okay, yeah, no, wait. We need to do this, yeah. Only if that is true as well. So there we go. So we jump. If we should jump, we jump. If it's not this type, it's going to be an exit code, so we're looking at that. Actually, yeah, I think this is always going to be a location. Do you have an is type? No, you don't. If it's not always a location, we can just add this check here. It's not big deal. Learning multiple languages is a bad choice rather than mastering one language. I don't think so. I mean, yeah. The thing is, like, a lot of languages are the same. And the things that you learn in one language can be brought over to other language. Like, it's I think it's better to have I mean, there's no reason why you should just stick with one language. Like, you can spend, like, once you've learned a language, it's not really the language that you've learned that is gonna be the thing that you're gonna keep on mastering. It's more the libraries, the frameworks, the type of programs that you're doing that is gonna be what you're trying to, like, learn about. That you have to learn more and more. Is like some new framework comes out, or new library, or, you know, there's so much stuff out there that you need to learn that it's not really, you know, a specific language that is going to be specifically what you're probably gonna, you know, stick around and be mastering. You know, it's gonna be like design patterns and stuff like that as well. Your aim is job. Yeah, so then you should look around in your area where you want to work and look at what they actually want you to know. So they could be, let's say you have a lot of Java jobs, then I guess you should go for Java. If there's a lot of Python jobs, then, you know, learn Python. That could be a guide for what you need to learn. If your aim is to get a job, do that. What keyboard do you use? It's DAS keyboard. DAS keyboard. It's some kind of mechanical keyboard or something. I don't know. I'm not a keyboard nerd. I just like these kinds of keyboards for some reason. Replace. Yeah. Okay. So that should be better, hopefully. Exit Unifield, exit code while field header is still active. Instruction 4. Okay, it actually still is an error over here. Well, address is active. Are we losing? We could be losing the type information. That is totally possible. Where's the if else here? So here's the condition. We compile the expression. So that should have the type information. And let's see. We set it to that. Yeah, so it should actually have the type information. Okay. Left resolved. Oh, wait. Left does have the type information. This thing. Wait, but that's an expression. Unary. Maybe we inherit it with unary. So it's like, yeah, this is just an exit code. This though, we should like, yeah, okay, so neg result, we should inherit the operand type yeah. Oh, we still get it. Okay. I'm going to log out. Wait, but it's an address. So if this is location, okay. Condition T. So that's the tag. We get the tag. Okay. It's a location. Right. And what is the type? It is a struct type. Okay. And I'm guessing we don't go in here. No. Okay. Oh, I see. We can do like F here. Oh. Okay. Format. We could maybe write out the whole thing. Well, that's the type, so I guess that will be formatted. So field name and type. Okay, let's just do new lines, whatever. Wait, thread and close. Okay, this is not correct. This is not correct. Yeah, so this is the execution. This is not the execution result. This is the execution, whatever it was called. Yeah, it's this one here. Execution handles struct type. Good evening, Ron Dev. Okay, so right. Oh man, do we want to do with capture? Okay, you know what? I'm at the end of my energy with this one. I need to go now, but yeah, this was way more than I thought it would be. But yeah, we got started on logical operations here, which is really nice because there's only this one left and redirections left, and then we're done with Runic. So, well, for the MVP at least. So, yeah, really nice. We're at the end stretch of this one. But yeah, this was way more tricky than I thought. I mean, I think it's mainly because we don't really have a lot of utility when it comes to the compiler. So there's like a lot of things are like ad hoc, you know, just spaghettied in there. And so when it comes to things like this, I was like, well, we already sort of have mechanisms for kind of doing this. But then it was like, well, it was not exactly the same. And since we're dealing with executes from like execution results, it's also a bit different. So, but yeah, we got a long way, I think. We have a few possible pieces left to put in place before this will work. And then we'll jump on the redirections hopefully next time. And I think in the meantime I will actually try to ask AI to see if we can get this working a little bit quicker. So yeah, that's gonna be it for this time. So yeah, thank you very much for joining me, and I'll see you next time. Have a nice day.